The last new thing in this section that we need to talk about is solving rational inequalities. First off, you need to understand what a rational inequality is. A rational inequality is any inequality that has variables in the denominator. And they're solved very similarly to quadratic inequalities, meaning we have to make a test line for them as well. But they do have little quirks that make them a little bit more difficult, and several little things you need to be very careful of and remember. So let's just sort of talk through a list of the steps we need to take. The first thing to solve rational inequalities, just like quadratic, we need the right side to be 0. That's our very first thing. The second thing is the place where a lot of people get into trouble. When we solve a rational equation, we multiply through by the least common denominator to make the denominators disappear. We multiply both sides by the least common denominator. You are not allowed to do that with rational inequalities. You are never allowed to multiply through by a variable with an inequality. What you have to do instead is you actually have to obtain an LCD. You have to get a least common denominator on the left side. Never multiply through by a variable. Does anyone know why we shouldn't multiply through by a variable? Anyone? Let's say I multiply both sides by, I don't know, x plus 2. That's fine in an equation, but when I multiply both sides by a negative with an inequality, what do I have to do to that? You have to flip it. Well, how do I know if x plus 2 is negative or positive if I haven't finished the problem yet? Do y'all understand that? So if you multiply both sides through by the common denominator and it contained a variable, you wouldn't know whether to flip it or not. So you cannot multiply through by a variable. That forces you to get a common denominator rather than multiplying through by a common denominator. So that makes it a little bit harder. Once you do obtain the least common denominator and you have one big fraction on the left, all you have to do is solve the top and the bottom equal to 0. So whatever it takes to set the top and bottom equal to 0, solve it, and those are the numbers that go on your number line. Okay, so once you have your number line, it's just like before. You pick a test number from each section, plug it back into the original or either somewhere very close to the original. Doesn't really matter what step you plug into. And then you see where it's true or false and shade where it's true. Now, after you shade where it's true, you have to decide whether to use parentheses or brackets. You can tell based on the problem. So we can see here that this is less than or equal to. So we're probably going to have brackets in our answers. However, because these have variables in the denominator, sometimes some of the numbers on your number line are going to be restrictions. It's where the bottom goes to 0, not just the top. So we have to set the top and bottom equal to 0. You are never allowed to put a bracket on a restriction. So you have to know at the end that if you're using brackets to go change the ones on the restriction back to parentheses. So it's a lot you have to keep straight there. Never put a bracket on a restriction, because a bracket means that it can equal that, and we can't ever let it equal a restriction. Never use a bracket on a restriction. So it sounds like a lot of work, but it's not really that bad once we get started. Okay, let's try this. You have x squared minus x minus 2 all over x squared minus 4x plus 3 is less than or equal to 0. The good news is that it's already 0 on the right, and the better news is it already has a common denominator. It's already one big fraction on the left. So we can just start taking the top and bottom apart, setting them equal to 0. There's a quadratic on top and bottom, so I'm going to go ahead and try to factor this. The top factors into x minus 2 and x plus 1, and the bottom factors into x minus 3 and x minus 1. And I want all of that to be less than or equal to 0. How many numbers are going to go on this number line? 4. There are 2 from the top. The top, if I set those equal to 0, yields 2, negative 1. The bottom yields 3 and positive 1. So there are 4, which means that number line is going to be broken into about 5 pieces. Let's look at it.
Can you go ahead and find your restrictions?
Yes, definitely. If you want to go ahead and mark your restrictions so that you'll know which 2 are restrictions.
3 and 1.
Yeah, these 2 right here are restrictions, and that means they cannot have a bracket when we get to the end. Okay, but you still have to put them on the number line. You just can't put a bracket on them. So, here's our number line. We need to make sure we get these in the right order. So we have negative 1, positive 1, positive 2, positive 3. And you can see that it divides my number line into 1, 2, 3, 4, 5 pieces. That means I need 5 test numbers to plug back in. 5 test numbers. So let's pick our test numbers. I think we should pick negative 2. What's the number between negative 1 and 1? 0. So I don't like when we have to use a decimal, but we're going to have to get something between 1 and 2. I'm going to use 1.5. And any number between 2 and 3 would be 2.5. And then for our last one, I need something larger than 3. So I guess 4. I'm kind of out of room here. We'll do positive 4. Okay, so let's take a couple of minutes. Let's go substitute those numbers into the original. And see what we get. I don't know if you're comfortable doing this. I like it, so you can think about it. If you go to y equals in your calculator and you type the left side in using alpha y equals, go to your calculator, go to y equals, and type in the left side, you can make a table. Would you guys like to try it right now? See? Do you want to check it that way instead of storing and doing each one of these separately? You don't care? Okay, let's look at that for a second. So here's our calculator. We're just going to type the left side into y equals. Take us just a minute. We'll go to y equals. Oh look, I think it's already in there from the last time I used it. Is this the same problem? Yes? X squared minus x minus 2 over x squared minus 4x plus 3. Okay, now the only way this will work is if you have it set up in the correct format. Remember that you need your table set up to be in Ask Auto mode. So if you go to second table set right there, you notice I have it in Ask Auto mode. That's going to allow me to manipulate my table, and I'll get to pick the x values that I substitute. So then we do second graph, go to the table, and I think I already still have them in, but if I delete them out, we can check them together right now. What was the first one? Negative 2. So negative 2 gives us positive 4/15. So negative 2 gives us positive 4/15. So positive 4/15 right here. And I want to know, is that less than or equal to 0? Is that true or false?
False.
That's false. So this one doesn't work. So this segment is out of the question. Now let's plug in 0 and see what we get. If we go back to our table and we put 0 in, when I type 0 in, I get negative 2/3. Negative 2/3. So negative 2/3 is less than or equal to 0. True or false?
True.
True. So let's shade that piece. That piece right there, the second piece, is true. When I put 1.5 into my table, I get the decimal positive 1.6667. So positive 1.6 repeating is not less than or equal to 0. It's false. So here's false. What happens when you put in 2.5 to your table?
Negative 2.3.
Negative 2.3, which is less than or equal to 0, so it's true. So we're going to shade there. And finally, if we put positive 4 into our table, what do we get? We get positive 10/3. Is everybody following along? Positive 10/3. Positive 10/3 is not less than or equal to 0. It is false when I plug it in. So that's pretty much, that's all I have. Only those two pieces make this work. Now I just need to put parentheses or brackets around. Well, for everywhere that's not a restriction, I'm going to put a bracket. But on the two restrictions, the 1 and the 3, I have to put a parenthesis instead. This is a bracket, and this is a bracket. But because 1 and 3 are restrictions, we have to put parentheses on them. And once you do that, you can see what your intervals are really easily. Negative 1 to 1, unioned with positive 2 to 3. That's how we solve a rational inequality.